One way to graph exponentials is by using transformation analysis. In other words, you think about an exponential function, and you look at this and say, what are all the things that happen to it that makes it not look like a normal exponential function, right? So we've got a -5 over here. That's a shift down. We've got a ×3 over here. That's a vertical stretch, and so on and so on. The problem is, when you're doing so many transformations, like we've got 4 or 5 transformations here, it gets complicated. So what I want to do instead is look at some key features. This really is a much faster way to graph this thing. I'm going to start with the most important key feature right here. When you've got an exponential function, this is real easy. This is the horizontal asymptote. Okay, so all we have to do is look at whatever was plus or minus, whatever was added or subtracted from the exponential, and that is our horizontal asymptote, in this case, -5. So I would just draw a horizontal line right here. Okay. Now, that's the easy part. Now we move on into the next part, which is not even that bad. We're just going to find 2 points, any 2 points, and I can, from those, decide the approximate shape of this function. And the way I'm going to do it is basically guessing. I'm going to guess some nice numbers. Now, you could sit here and say x equals 0, x equals 1, x equals 2, and so on. You can guess all day, and you probably won't take too long. I prefer doing it this way. I'm going to say -3 minus x equals 0, because I know if the exponential right here, if I know if that guy is 0, that's going to be real nice. 1/4 to the 0 power is going to be real easy to figure out. So -3 minus x equals 0. That means -3 equals x. And now I plug that back into the equation, and I say, hey, what's f of -3? Well, it's going to be 3 times 1/4 times -3 minus -3 minus 5. Okay? So we simplify now. That's all that's left. -3 minus -3, that's -3 plus 3, that is 0. That was by design, right? We wanted a nice, easy exponential. And this becomes 3 times 1 minus 5, which is just 3 minus 5, which is -2, okay? So there's my x and y values for this point. It's going to be x equals -3, y equals -2. And that's that. So I can plot that on this graph. Let's see. X equals -3, y equals -2. That's going to be right around here. Okay. Now the next thing I have to do is plot another value. And what you might try first, okay, let's say you don't really know where you're going. Let's just pick another nice value of the exponent. We're used to picking something like -3 minus x equals 1. And I'm going to show you why this is not the best idea. If you plug that back into your equation, you'll get something like this. Y equals 3 times 1/4 to the 1 power minus 5. This is 100% correct. It's also not very helpful, because what this is going to turn into is 3/4 minus 5, which is a fraction. It's kind of, it's not wrong, but it's kind of ugly, and you're going to have a hard time plotting it on a computer graph, because the computer insists that you use whole numbers when you plot points. So, okay, let's just pick something else that would work out great. Now, if you look at this part right here, I want to examine this. This is where the troubles come in. You're taking a fraction to a positive power. Of course, you're going to get a fraction. Fractions to 0 were easy, but what if we took a fraction to a negative power? Let's try that. I'm going to choose -3 minus x so that it is -1 instead of +1. And now look what happens. Y equals 3 times 1/4 to the -1, right? I chose my -3 minus x to be equal to -1 minus 5. And now this is going to be 3 times, well, if you're worried about this part, remember that 1/4 is just 4 to the -1. Okay, I'll do this in steps. And when you take an exponential and you raise it to another exponential, like I'm doing right here, those just multiply together. So we get 3 times 4 to the 1 minus 5. And this is quite nice again. We're back to integers. So this becomes 12 minus 5 equals 7. Okay, so my coordinate will now be -1, 7. Okay, that's the key point I found. This one was a little bit more of a speed bump, and you have to recognize what's happening here. It's because of that guy right there. That fraction makes it just a little bit different when you're guessing the values that go in the exponent. So I'm going to plot this point, -1, 7. That's like over here. And now I've got 2 key points. I've got an asymptote. All I need to do is connect these things and then curve to approach the asymptote. And that's that.